Hi everyone, this is for Module 3. I think it's like the third video, and we're starting on page 103 with Mendelev's periodic table. So periodic means repeating, and he organized the known 63 elements at that time in increasing order by atomic mass. So the periodic table was organized by repeating patterns that he found. And he left gaps where he predicted that there would be elements still to be discovered. And later, 40 years later, the protons were discovered. And so now we have the modern periodic table, and it works pretty much the same way that Mendeleev came up with. So he was very intelligent. So how he organized this was that the rows across are the periods when you're going across the periodic table, and then the columns going down are groups or families. And those groups, the columns going down, all have the same number of valence electrons. So you might be wondering what a valence electron is, and we'll go over that in just a little bit. But first I want to talk about each of those squares on the periodic table. So this is the information that's mostly going to be there. Okay, so see the H for hydrogen, that's the symbol. And then that top number on the left corner is the atomic number. And that tells you how many protons that the element has. And then the bottom left number is the atomic mass. And remember, that is the number of protons and the number of neutrons and their mass in total. So that's what you're going to find on your periodic table. So on page 103, remember that your columns are your groups, so going down. And on page 103, you'll notice that these top elements here have an A after them. You see that? And then down here, there's a capital B. And so the A is for the main group elements, and then the B is for the transition elements, and some periodic tables will have this, and some will have the group numbers numbered 1 through 18. So hopefully you can see this, but on this periodic table, it has the group numbers 1 through 18, and then with Roman numerals, it also has the 8 groups with the A, and then the B is not on here, but the B would be the transition metals down here. I'm sorry, I totally said that wrong. The B is here, so that would refer to this group down here, so that would be 8B, and then 8A would be over here. Hopefully this is not too dark for you, but so if you're talking about the group numbers 1 through 18, or using the 8A group numbers in the homework that I gave out, you can use either one for your answer. Both are correct. But the 8A group columns are important because it tells us how many electrons are in the outermost, the highest energy level for that atom, and those are called the valence electrons. So this is where I'll talk about those. The valence electrons are the electrons in the highest energy level of an atom, and those are the ones that play a role in the chemical reactions. So let me show you. So if you look at your periodic table, you'll find that there's a hydrogen here and a helium here in their own period across the table, and that's because their energy level only holds 2 electrons. So they have one. I'll show you. So here's hydrogen, and so this would be its nucleus, and it has 1 proton and 1 neutron, but I won't draw those. And then this is its outermost energy level. It only has 1, and it has 1 electron here. And then, so this is its valence electron right there. And then this guy over here would have 2 electrons, 2 valence electrons there. Then you could look at, let's do beryllium. And so it has an atomic number of 4. And so you can tell that it's got 4 protons. 4 protons. So it has 4 electrons, right? I didn't draw the protons or the neutrons, but they're in the middle in the nucleus. And so when we're drawing the electrons, the first energy level is 1 orbital, so it can only hold 2 electrons. And then you have to go to the next energy level. And so remember, it has 4 electrons, so we put 1 here and 1 here. And that means it has 2 valence electrons. So even though it has 4 electrons total, only 2 of them are valence electrons because they're in the outermost energy level, and these are the ones that are going to be reactive in chemical reactions. And actually beryllium is very reactive, and that's because this normally can hold up to 8 electrons, and it only has 2. So beryllium just wants to give those away, and so it's very reactive. And if you go down one more back on the periodic table, you get lithium right there. It has an atomic number of 3 lithium. And so it's got three protons. That's what the 3 atomic number means. And so you know it has 3 electrons to balance it out. And it's got only 1 valence electron. And so it's going to be extremely reactive because it just wants to give that one away. So as you move along to the right along the periodic table, as you move to the right, the valence electrons increase. So this one right here, it's going to have 1 valence electron, 2 valence electrons over here, 3 valence electrons, 4, 5, 6, 7 valence electrons, and then you have 8 valence electrons. Let me show you why that is special. So let's do neon. So it's in group 8A, right there. Can you see that? So neon has an atomic number of 10. So it has 10 protons, so we know it has 10 electrons. So let's go ahead and fill them in the energy levels here. So the first energy level is only 1 orbital, so it can only hold 2 electrons per orbital. So 1, 2, and this one has 4 orbitals, so it can hold 8 electrons, and it has a total of 10. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. Did I count right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll put 10 right there. And so it has a total of 10 electrons. And so this energy level is full, and this energy level is full. This one can hold 8. It has 8 here, 2 here. It's all filled up. It's happy. It doesn't want to give any away. It doesn't want to gain any. And so this whole group right here, the 8A group, these are very non-reactive actually. Okay, so we're going to go through each of the 8 groups, starting with group 1A in this column right here. And so hydrogen's actually not part of that group. It's just put there because it still does have 1 valence electron. These all have 1 valence electron, and they're in group 1A. Okay, like we talked about before, they're very reactive because that energy level usually holds 8 electrons and it's only got 1 in it. And so it really wants to just give that electron away and react. They're malleable soft metals. And it talks about in your book that sodium can be cut with a knife. So that's soft. And it's very reactive. But if you notice, if it's bonded with chlorine, it's not so reactive. That's just table salt, right? And then as you go down the periodic table there, they become more and more reactive. So lithium's the most Lithium is the least reactive of this column, and then sodium gets more reactive, and potassium gets more reactive, and then as you go down, it's just more and more reactive, and I think, yeah, this one's radioactive down here. The next one on the periodic table is group 2A. So then how many valence electrons do all of these guys have? This column, this group, as you can see, is the orange group there. They have 2 valence electrons, and they're actually the second most reactive on the periodic table. When they're mixed in a solution, they form an alkaline solution. So that just means that they form a pH greater than 7 when mixed in solutions. They're silver or gray metals, they're soft metals, and then I drew a picture of magnesium to just show you it has 3 energy levels, but on the outermost energy level it has 2 valence electrons. And then we have the boron group. So you can actually see it starts with boron right there. That B is for boron, if I could focus on it. Group 3A. And boron is a metalloid, which means it's not quite a metal, but it shares characteristics of a metal, so it's kind of metal-like and non-metal-like. And then the rest going down are metals, and you'll see that as kind of a trend that a lot of these groups will start out as either non-metals or metalloids, and then as you go down in the group, they become metals. So there's boron, the B, and it's used to make glass beakers. There's aluminum, I'm sure you're familiar with aluminum, and then there's gallium, it's used to make LEDs, and your text goes into some cool uses of the different elements that we're talking about in the different groups, so be sure to read that. It's fun information. Next is the carbon group, group 4A. So how many valence electrons does it have? 4, and it starts with carbon. Carbon is what you're going to find when you study organic chemistry, because all living things have carbon in them, and carbon is a nonmetal. And then silicon and germanium are metalloids, and then lead and fluoronium are metals. So you can see the trend going down in the group is that the metallic characteristics of the elements increase as you're going down in the group. Next is the nitrogen group, 5A. It starts out with nonmetals, nitrogen and phosphorus, and then there's metalloids, arsenic and antimony, and then there's metals, bismuth and moscovium. So same thing, the metallic characteristics increase as you go down group 5A. Group 5A, the nitrogen group. Guess what the next group's called? The oxygen group. So the oxygen group, group 6A, it's also called the chalagen group, and you'll want to note that because the handout that I gave for homework, it actually says the chalagen group, and it doesn't even say oxygen group, so they're the same thing, just so you know. And the same thing, the metallic characteristics increase as you go down that column. After the oxygen group, we have the halogens, and these are special. These are special because they're very reactive. Also, when they react with a metal, they form a salt. And they're all non-metals. I wanted to show you why they're so reactive. Let's see. So I chose, I'm totally blanking on what that's called. Fluorine. Okay, so fluorine has an atomic number of 9, so it's got 9 electrons here. So let's fill them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. There should be one right here to fill this in completely, this outer energy level. Okay, so it's got 1, 2, 3, 4, 5, 6, 7 valence electrons, and because this outer energy level holds 8 electrons. There's that empty space there, and it wants to grab an electron from another atom to fill that space, and so it's very reactive just for that reason. It's also right up against this next group here, the noble gases, and you'll find out why those are special in just a moment. Okay, so the noble gases are on the far right of the periodic table, that dark purple group there, and they are non-reactive. Why are they non-reactive? Well, it's because their highest energy level is filled. That second energy level, when I was drawing them, it could hold 8 electrons, and that one is full of 8 electrons for all of the noble gases, and so they don't want to gain anything. They've got nothing they really want to lose, and so they're just non-reactive. They're non-flammable. They're odorless and colorless. However, oh, and I need to mention that it's all of them except for, and I don't know why it's not a different color on this, but it does not include the helium. It starts at neon for the noble gases. Even though they're colorless, they are used in neon signs because when electricity is passed through them, they glow at different colors, and that's true for all of them except for radon. So I think that's about all I want to tell you about this. Remember that these in here are the transition metals, so you can familiarize yourself with, some of the common ones that you would know, like iron, cobalt, and then a lot of these down here, they don't actually exist in our world unless they're created in a lab, and they only exist for like seconds or a minute because they just react and they don't stay in that form. So hopefully you enjoy studying the periodic table of elements and kind of familiarize yourself with it. Good luck.